Titration. So in this video, we are going to have an in-depth discussion on titration, and I'm going to provide you with guidelines and tips that will not only ensure you have a deeper understanding of this concept, but you also manage to get everything in your titration practicals. So let's dive in. Now, titration, also known as volumetric analysis, is a process which is done to determine the concentration of an unknown solution using another solution whose concentration is known. Okay, let's break that down. Imagine you have two solutions, solution labeled A and solution labeled B. Now, you know the concentration of solution A, but would like to determine the concentration of solution B. So you can do this through the use of titration. So what happens is that you're going to take the solution whose concentration you know, in this case that is solution A, place it in a burette and slowly add it to the other solution, which is going to be in a flask. So this will continue until the reaction becomes complete. Now you may ask, how would we know whether the reaction is complete? Whether all the analyte has reacted with the titrant? This is where the indicator comes in. So an indicator is used to determine the endpoint, when the reaction is now complete. Now an indicator is added to the solution in the flask at the beginning. So when a color change is seen in the resulting solution, it indicates that the endpoint has been attained. Now what are indicators? Acid-base indicators are substances that give a certain color when mixed with an acid solution and a different color when in a basic solution. Now these are used in titration to indicate the end point of a reaction when the reaction is complete. So usually in titration, around 2 to 3 drops of an indicator are used. This is more than enough. So the more common indicators that are used in titration are as follows. And those are the color changes that you would note when placed in a basic solution, neutral or acidic solutions. Now, I want to make a point. There are certain titrations that don't require an external indicator to determine the endpoint. Now, this is because in such titrations, you'll find that a certain reagent is used which changes to a different color once the reaction is complete. So the use of the indicators is simply unnecessary. Let me give an example to make this clear. Imagine you're using potassium manganate 7 in a titration experiment. So this is being titrated against another reagent. Now the potassium manganate 7 solution is purple in color. When it undergoes certain chemical reactions, it changes to colorless. So at the end of the titration, it changes from purple to colorless. So this change in color is enough to signal that the endpoint has been attained. So in such titrations, which are known as redox titrations, there is actually no need for an external indicator. The reagent itself serves as an indicator. It lets you know when the endpoint has been attained. Now moving on to the apparatus that are used in titration experiments. So I'm going to focus on the most important ones, and these are the burettes and the pipettes. So let's start with the burette. Now the burette is an apparatus that is used to transfer accurate volumes of a solution. So it consists of a long narrow tube with a tap and a jet at the bottom. So it's graduated from 0.0 cubic centimeters to 50 cubic centimeters. It also has larger intervals of 1 cubic centimeters and smaller intervals of 0.1 cubic centimeters. So the burette is essentially used to deliver the titrant into the flask containing the analyte. Okay, let's pause there. In case you're wondering, okay, what is the titrant and who is the analyte? Let me make it clear. So the titrant is simply the solution whose concentration is known. This is usually placed in the burette. The analyte is the solution whose concentration is unknown and which we seek to determine from the titration. Now this is present within the flask. So how do you use a burette? Now number one is that before using the burette, you're supposed to rinse it with distilled water. After this, you're supposed to rinse it with a small amount of the titrant. The solution that you're supposed to place in the burette, then you're supposed to pass a small amount of this solution through the burette. After this, of course, you can then fill it with the titrant. So to allow the titrant to flow out of the burette, you're going to slowly open up the tap to allow the titrant to flow out in small amounts at a time. So as the titrant flows out, what you're going to do is that you're going to swirl the contents in the flask in order to mix them thoroughly. So remember, you are reacting the titrant from the burette with the analyte that is going to be present within the flask. So with every titrant that flows out, you're going to swirl the contents within the flask to mix them. So when you see the reaction nearing the endpoint, what you're supposed to do is that you're supposed to slow down the flow of the titrant such that you add 1 drop at a time and swirl after every drop until the endpoint is reached. Just a reminder, how do we know the endpoint has been reached? Because we are going to observe a change in the color of the indicator. So after the endpoint has been attained, you're going to read the volume of the liquid in the burette that has been used. So what you do essentially is that you're going to look at the bottom of the meniscus in the burette. So the volume is always read at the bottom of the meniscus. Your eye should be at the same level with the meniscus as shown below. So whatever volume you get, that is going to be the volume of your titer, the amount of titrant that was used. Okay, so that's that on the burette. Let's move on to the pipette. Now, when it comes to the pipette, this is an apparatus that is used to deliver a specific volume of a solution. So it has an enlarged part which holds most of the liquid. Above and below the enlarged part, you're going to have a narrow tube. Now, the pipette also has a calibration mark. So the calibration mark is usually found around the upper tube. It shows the level of the specified volume that it fills. Now, when it comes to pipettes, a lot of the pipettes have a capacity of 25 ml. So if you were to suck in a particular volume and it reaches the calibration mark, that simply shows you that the volume within the pipette is 25 ml. So how do you use a pipette? Again, just like with the burette, before you use a pipette, you should first rinse it with distilled water, followed by a small amount of the solution you are supposed to draw. The pipette is then filled by sucking the solution up to the calibration mark. Now, sucking can be done using the mouth or a pipette filler, although a pipette filler is recommended because some of the chemicals that are to be sucked can actually be toxic. So it's safer for you to use a pipette filler in order to avoid poisoning. So the volume that is pipetted is usually 25 ml, and this is constant for all titration experiments. The only changing volume is that of the titrant, the one that flows out of the burette. Now, after every titration you do, you're expected to record your data in a table. So usually you're provided a table, and what you simply have to do is just fill in the values. Now, in most cases, you will be expected to carry out 3 sets of titration, although in a few cases, it's going to be just 2. So if you look at the table, you can find out whether it's supposed to be 3 or 2, although as stated in most cases, it's usually 3. Now, let's move on to the second part. In this part, we are going to discuss the following: guidelines on what is expected from you, the student, the mistakes that you should avoid, and how marking of titration questions usually takes place. Number 1 is where we have the table. Now, this is the first question that you have to answer. You have to complete the table. Now, the table has 4 marks, usually has 4 marks, and the marks are divided as follows. You have 1 mark for completing the table, another for the decimal place, another for accuracy, and the final one for the final accuracy. So those are 4 marks in totals. Now, what I'm going to do is I'm going to discuss each mark, how each mark is awarded, and the mistakes that you need to avoid. So let's start with the first one. What does it mean to complete the table? Now, a full mark is awarded for completing the table with the results of 3 complete titrations. That is, all the 9 boxes in the table should be filled. Now, this mark is awarded regardless of whether the values used are correct or not. That simply means that whether you used a correct value or whether the value is wrong, as long as you fill in all the 9 boxes, you get yourself this mark. How easy is that, by the way? But there's always a but, isn't there? There are certain mistakes that you should avoid so as not to lose this mark. And the mistakes are as follows. Number 1, wrong arithmetic that is caused by wrong additions or subtractions. Okay, what do we mean by this? Now, if you have a table such as this with the initial and final burette readings. Now, initial burette reading simply means the volume of where the volume of the solution was at the beginning of the titration, and the final where it was at the end of the titration. Now, if you have the following values and you need to find the volume of the solution, all you need to do is find the difference between the two. Now, the difference will let you know the volume of the solution that was used. Now, if you look at the table, you'll find that when it comes to the difference, the subtraction was done wrongly. So instead of having an answer that says 12.5, the answer is actually 12.6. So this makes it wrong. Now, this will cause you to lose half a mark from your table. Another mistake that should be avoided is the inverted table. Now, this occurs where the initial burette readings are exchanged with the final burette readings. Now, in the case of titration practicals, you have a table that is already provided for you. And from the table, you can clearly see where the initial and final burette readings should be. All you need to do is simply transplant the volumes correctly. But sometimes students make a mistake in that instead of recording the initial burette readings under the initial burette readings, they do so under the final burette readings. You know, they invert them, they exchange them. So initial zinaenda kwa final na final zinaandikwa kwa initial. So this costs you. The third and final mistake is unrealistic titles, you know, unbelievable titles. So if you have unbelievable titles, you know, questionable ones, which are less than 1 or more than 50, guys, the maximum volume of a burette is 50. How can it be possible for you to have more than 50 and less than 1? Impossible, right? So if you have such unrealistic titles, such as in this case, what will happen is that you're going to lose half a mark. So if you make any of these mistakes, you're going to be penalized half a mark. And that is that. But I'm sure as of now, it should be very easy for you to score this mark. Now let's proceed to the next marking point of the table, and that is the decimal place. So a full mark is awarded if the decimal place is used consistently. Okay, what do I mean by consistently? You can either use 1 decimal place or 2 decimal places. But if you decide to use 1 decimal place, it should be used throughout. If, however, you decide to use 2 decimal places, then again, all the values should be to 2 decimal places. But the second digit, the second figure after the decimal place should either be a 0 or a 5. So for example, if you have 24.8 and you decide to use 2 decimal places, then it should either be 24.80 or 24.85. If for example, you have 25.6 as your volume, as your titer, then it should either be 24.60 or 24.65 cubic centimeters. Again, you can use 1 decimal place, and I highly recommend to students to use 1 decimal place and stick with it throughout because it's easier for you to remember. Now, I want you to note 2 things. Number 1 is that you will be penalized fully if you are not able to use the decimal places consistently. If you interchange between 1 decimal place and 2 decimal places, then you're not going to be awarded this mark. If you also use whole numbers, you know, maybe 25 cubic centimeters, 26 cubic centimeters as such, then you will also be fully penalized and awarded no marks. So it's either 1 or 2 decimal places. Now, the only difference is when it comes to 0. If you were to write 0.0 or 0.00, there's literally no difference. So you can use either. It doesn't matter when it comes to 0 cubic centimeters. Okay, moving on to the third marking point of the table, accuracy. So for this mark, the 3 titles of the student are compared to the school value. So when you talk about the school value in titration, this refers to the average value that is obtained by a teacher or a lab technician who did the practical. Now, whatever value they get is what is referred to as the school value. Now, when you have your table, you're going to have 3 titles. So what happens is that for this mark, marking is done as follows. If any of your 3 titles is exactly the same as the school value, then you get yourself 1 mark. So for example, if the school value is 25.5 and you have 25.5 as one of your titles, then you get that 1 mark. Now moving on, if any of your titles is within 0.1 cubic centimeters of the school value, you also get yourself 1 mark. Okay, what do I mean by this? If there's a difference of 0.1 cubic centimeters between your titer and that of the school value, then you also get this mark. So for example, if the school value is 24.9 and you got 25 cubic centimeters, this will get you 1 mark because the range is within plus or minus 1. So if the titer is 24.9, that means that the acceptable answers are between the range of 24.8 to 25 cubic centimeters. Anyone who has a titer within this range will get 1 mark. Now, what about if your answer is within a range of 0.2 cubic centimeters? So, for example, the school titer is 24.9 and you have 24.7. So, this again will not get you the 1 mark, but it will get you half a mark. So, if you have a titer that falls within the range of 0.2, in our case, for example, falling within the range of 24.7 to 25.1, then you get yourself a half a mark. Last one, what if none of your 3 titers falls within the range of 0.2? Then unfortunately, no mark is awarded to you. So for example, if the school titer again is 24.9 and you have 24.1, 24.3 and maybe 24.5, then no, you will not get a mark for the accuracy. But I want to tell students this, it's very difficult for students to get this mark. So never be disappointed that you didn't manage to get the accuracy marks. You should be focused on getting the marks that are easier for you and what lies ahead when it comes to calculations. Now, the final mark when it comes to completion of the table has to do with final accuracy. But before I discuss this, I want to talk about principles of averaging. Now, when it comes to titration, immediately after the table, the question that usually follows is that you are asked to calculate the average volume of the titer. And this is very easy. All you need to do is simply take your 3 titers, sum them up, divide by 3. But again, there are certain rules that need to be followed. Now, the first rule is that the values that you're supposed to average should always be within a range of 0.2 cubic centimeters within each other. That simply means that any of those values that you take should have a difference of 0.2 cubic centimeters or less with one another. So for example, if we have the following titers, 14.2, 14.3 and 14.4. Now if we look at these 3, all of them have a difference of 0.2 or even less. So we can use all of these 3 values because they fall within the range of plus or minus 0.2. So what you're going to do is we are going to take all 3, sum them up, divide by 3 to get our average volume used, which in this case is going to be 14.30 cubic centimeters. Let's do another example. Imagine I also have 3 titers and the first titer is 25 cubic centimeters, the second 25.1, the third is 25. In this case, you're having titers that have a difference of 0.1 or even less with one another. So you can take all 3, sum them up, divide by 3, get yourself 25.03 cubic centimeters as the final answer. But if you have titers that don't all have a difference of 0.2 or less, then you're going to pick 2 that actually do. So for example, I have 3 titers over here, 25.6, 25.2, and lastly 25.3. Now, if I look at the first one, 25.6, if I were to take 25.6 and 25.2, these 2 values actually have a difference of 0.4. So it's not acceptable. What about 25.6 and 25.3? They have a difference of 0.3. Again, this falls out of the range. But I can take 25.2 and 25.3. These 2 values have a difference of 0.1, which is acceptable because it's below that of 0.2. So I'm going to take 25.2 plus 25.3 divide by 2 because there are only 2 values, and that will give me my average volume of 25.25 cubic centimeters. Now for this, you're supposed to have a correct mathematical expression. You're supposed to show how you arrived at your answer. So if, for example, you were to have 3 values, 25, 25 and 25.1, what you're supposed to do is you're supposed to show how you add these 3 values, then divide by 3 to get the final volume. This will get you 1 mark. So the first part accounts for half a mark and the last part accounts for the remaining half a mark. But if you were to place your expression as such, this will award you no marks at all. And the reason for this is because the divisor is missing. So it's an incorrect expression. Now, how about if you were to do the first part correctly, sum them up, show the correct expression, but when it comes to the final bit of calculation, you messed up, you gave a wrong value, then what will happen is that the first part will be marked correctly, which accounts for half a mark, and the next part will be considered wrong. And this is the principle of averaging. Now, I want to go back to the final marking point of the table. Remember, we had 4 marks for the table. 1 for completing the table, decimal place, accuracy, and the last one, final accuracy. Now, I want to discuss this last one. Now, when it comes to final accuracy, the average value that you get is compared with the school value. Now, I want to make something clear. The school value is used twice. Once in accuracy and the second time in final accuracy. Now, in the case of accuracy, what is simply done is that the examiner looks at the titers. So if you have any one titer that falls within the range of the school value, you get yourself that mark. But when it comes to the final accuracy, the average that you get from calculating your average titer is what is now compared with the school value. So marking is done as follows. If the average volume is exactly as the school value, you get 1 mark. If the average volume is within plus or minus 0.1 from the school value, you get 1 mark. If the average volume is within plus or minus 0.2 from the school value, you get half a mark. But if the average volume is more than plus or minus 0.2 from the school value, you get no marks. Now, let me give an example to make all of this clear. Imagine that the school value is 25.2 cubic centimeters. So the following results will be marked as shown. If a student was to get 25.2, then that student will be awarded 1 mark. If the student was to get 25.1, then the student will also be awarded 1 mark because the average value falls within a difference of 0.1 from the school value. If the student was to get 25 cubic centimeters, then that is half a mark. And the reason for this is because it has a difference of 0.2 from the school value and therefore half the mark. And lastly, what about if the student was to get 25.5 or maybe 25.6 or maybe 24.9? There will be no marks, because this has a difference of more than 0.2 from the school value. Now, in our last bit, I'm going to focus on calculations of titration questions. So I'll give you guidelines that you're supposed to use when undertaking this. So number 1, transfer of values. So the values that you obtain in one question are going to be used in the next question. So for example, in the first part, after the table, you were asked to calculate the average volume. So this average volume that you calculated is what you're going to use in the next question. Now, when you transfer values, when you obtain a certain value in one question, you are supposed to transfer it intact from one calculation to the next. Okay, kizungu mingi, what do I mean? For example, if you got 25.5 cubic centimeters as your average value, when proceeding to the next part of the question, where you're supposed to be using this average value in your calculation, ensure it is the way it was when you got it in the previous part. So instead of approximating or instead of even rounding it off to 25, ensure that it's exactly the same as 25.5. Now, this happens, for example, in some cases, you'll find that students obtain a value such as 0.7, and they round it off to 25 cubic centimeters or even 25.5. This is wrong. The value that you get is supposed to be used exactly the way it was in the next question. Now, if you transfer it and change it somehow, it's going to be considered a strange figure. And therefore, you're going to be penalized for introducing a new figure. Now, what about in the case of units? Are you supposed to use units? And if so, how? Now, the units that you use should always be correct. So, for example, if it's a question that's asking you about volume, it should be cubic centimeters and not cubic square or centimeters or any other. Now, what about if it's about molarity? It should be molarity illustrated with a capital M. Now, I tell my students this. When it comes to units and you're unsure of whether the unit you have is correct or not, then don't write it at all. Just leave it out. You will not lose a mark for not writing the unit, but you're going to be penalized if you write a unit and it's the wrong one. So choose wisely. What about rounding of values? Now, students can either leave their answers the way they are, or they can be approximated. They can be rounded off. But when rounding off is done, there is a minimum number of decimal places that should be given. So let me break it down for you. If the question asks you for volume, then the volume should be rounded off to 2 decimal places unless you get an exact value. For example, if you are getting an average volume and you manage to get something like 25.1 or even 25 cubic centimeters, then let it be the way it is. But if you manage to get something that has more decimal places than 2, then you can round it off to 2 decimal places, but no less. Moles are always supposed to be rounded off to 4 decimal places. Imagine you got yourself this answer, 0.04351 moles. Now you can round it off to 4 decimal places and no less. So that means that you can round it off to 0.0435, but you can never write it as 0.043. You're going to lose that mark. Molarities should always be rounded off to 3 decimal places. So for example, if you get an answer whereby it's stated as 0.3481 m, so you can round it off to 3 decimal places, giving you 0.348 and not 0.35 or 0.34. That will cost you a mark. Now, in the case of temperatures should always be stated in whole numbers or to 1 decimal place, which is either going to be a 0 or 5. So, for example, you can set the temperature as 27 degrees Celsius or 27.0 or 27.5. Let's imagine the temperature is 33. You can set it in whole numbers as 33 as such, bus. Or it can be 33.0 or 33.5. If you choose to have temperature in decimal places, it can only be to 1 decimal place, and the first digit has to be either 0 or 5. What about when you write equations? Of course, this doesn't need to be said, but just as a reminder, equations in chemistry should be, number 1, correct. They should be balanced and they should have the correct state symbols. So all 3 conditions should be met. So if you have an equation that has not fulfilled the 3 conditions, then it's going to be penalized. And last but not least, always, my dear students, use a calculator for all your calculations in order to avoid any arithmetic errors. And this brings us to the end of this lesson. I hope that you've garnered a lot from it. See you next time.